Hey Fox, I can see there are a lot of people from different parts of India. It's quite awesome. Can you please let us know in the chat, have you ever worked with blockchain and related technology ever before? So that Doris have some idea about that as well.
Recently started exploring blockchain tech. Super interesting. I like that comment. Okay, you're studying it in your college curriculum. That's amazing because I really don't have that in my college.
Yeah, actually, my college has started honors course in blockchain this semester. So right from January itself, I will be studying in college itself.
Awesome. Okay, I guess Bhavna, let's start.
Yeah, sure. So hello everyone. I hope you all are doing well and enjoying your winters as well. So I think I would like to welcome you all in the amazing workshop of She Builds Hacks. She Builds is basically the India's largest diversity-focused hackathon. We packed up some amazing swags, networking opportunities, prizes, and unforgettable experiences as well. So you have an idea for an app, Web 3.0 project, hardware, and anything that you like. You can build this thing in a particular hackathon that is Shebit, and from 6 to 8. And we have some prize for you as well. So today we are give away 3 mystery boxes to our participants. And so hang tight and look out for the Google form that we will share in the chat itself at any time. So being active, it's quite an advantage for you all. So let's start. So today we have Doris with us. She is a senior software engineer at Concordium. So today she will be guiding us some building a front-end demo with browser wallet, and she will be also answering some questions that we have in the chat itself. So recap: the winning team of the Concordium track will receive $3,000, which is the highest prize in the
Uh,
hackathon itself.
Correction,
So
$300. Sorry.
yeah, sorry for that. So over to you, Doris.
Okay, hello everyone. I hope you're excited about learning something new about blockchains. So I will share my screen. Okay, I hope you're able to see it now. Okay, let's start.
Yes, we can see your screen.
Okay, so let's start. This presentation, it's the second part of the Concordium track presentation. So yesterday, I hope you already attended the first part, which my colleague Hasper gave, and he was talking about how to build smart contracts and how to deploy them on Concordium. And today we will continue from there and build a front end to the voting smart contract that we built yesterday. So in case you haven't seen the presentation yesterday, I highly recommend that you watch it. I think it was recorded, or you can also look through the slides because I think it gives you a good overview about how the whole development is on Concordium. But I will make the presentation already so you can still follow along even if you haven't listened to the first presentation yesterday. Okay, let's get started. So first, let's have an overview what you want to cover today. So we will recap the problem that we had yesterday that we wanted to solve on the with the smart contracts and the front end. And then we will talk a little bit about the front end integration, what this is and how this works. And then we will look into something which we call a browser wallet. So a browser wallet is something that allows you to talk to the blockchain via the front end. And that's a very important piece that we need before we can start. And once we have this set up, we can start coding some basic front ends. So we will show you how to initialize the smart contract from the front end. We'll also look into how you write how you send a transaction to the blockchain, to the Concordium blockchain. And then we also will read some data from the blockchain and display it at the front end. So these are the most basic things that you need to get started in your hackathon. And then we have some kind of bonus thing in the end. So we want to show you something really, really unique. And it's the identity feature that Concordium has. So if you stay until the end, you will see how to build a zero-knowledge proof with the browser wallet. So that's something special, and I hope you're going to stay until then. And then we also will look into why maybe you want to build on Concordium, what are the unique features, and we also give you a lot of resources that will help you to build your hackathon project. And if you have questions in the end, we can answer them as well. Okay, let's start it. We had a problem yesterday that we tried to solve. Let's look into this. So that's you. And you're an amazing developer, and you're always full of great ideas, and you also love music. And if you're maybe from Europe, you maybe know about this Eurovision Song Contest, which it's a competition where each country from Europe, they send in a group of musicians and they perform. And then in the end, every user in Europe is allowed to vote for their favorite performance. So technically, you just vote for your favorite country that participated in this competition. And as far as I know, this competition also might come to Asia soon. So it is an interesting use case. But of course, there's some rules, you know. So there's one very important rule, and that's that Mr. X, the user who votes, is not allowed to vote for their own country. And the reason for this is that maybe if you're a big country in Europe with a high population, then these people would probably vote for their own country, and it would be a disadvantage for smaller countries. And it's also the case that usually people prefer the songs that are written or in the native language. So in that way, we want to prevent that people vote for their own country to kind of get away from the bias that people might have. So that's not the rules of the competition. We cannot change them. But this rule is a bit difficult to achieve, actually. When you think about it, we are not 100% sure how they do it in the Eurovision Song Contest test. But they usually probably you call them and they will check, for example, your mobile phone number. And this kind of things you can easily circumvent. It's not really bulletproof. So we want to make a better system. And if you listen to this presentation, you can remember that, there was something that's what was called Concordium, and it had an identity layer on this blockchain. And maybe we can make use of this identity layer to solve our problem, that we prevent people from voting for their own country. So that's our goal. We want to achieve that. And yesterday you coded a smart contract. So today we'll look into how to code the front end. So the first piece, what we need is a browser wallet. So if you had your laptop or your computer, then there's not really a blockchain in your computer, and the normal user also will not have a local node running. It's actually quite complex, maybe for the average user. So we need to give them an easier access to how they can read and write or access the blockchain. And how this is done is that the user, that's maybe you, it opens a front end or web page in your browser, what people already are used to. And then you have something which we call a browser wallet extension. And it usually is a small button at the top right of your browser, and you click on it, and then it opens up something like this. It's the browser wallet. And this browser wallet, it's connected to the blockchain. So what the browser wallet actually does, it stores two things. It stores the private keys. So in this browser wallet, you have accounts. This literally, you can think about it like an account in your bank. And you need some private keys to access the funds which are in this account. So the browser wallet stores these private keys, which you need to keep very safe. And the other thing that the browser wallet also saves is it points to a server where a Concordium node is running. So it saves a link. So this link is done by the browser wallet. It connects to server where a local or where a Concordium node is running. And that way, the browser wallet can communicate with the blockchain. It can read and write from the blockchain. And we will look into this, how to do this, because it's quite different how you read from a blockchain, how you write to a blockchain. So to understand this maybe better, so reading is always for free because it's only simulated at a local node, so only at one node. While writing, you have to pay. So you have to pay a transaction fee because this transaction is sent to the whole blockchain network and all the nodes have to do some computation, and that's why you have to pay for the transaction. So writing is always expensive. Okay, I will show you how to download and install this browser wallet. So you can click on this link, but I will also show you how to get to this link when you at your home computer. So what you can do, you can just input Concordium developer documentation. And where you end, so first I need to go to the Chrome. The reason for this is because we will download the Chrome extension. So it's like these extension here, they are for specific browsers, and our extension, it works with Chromium-based browsers. And it's the biggest market share that the Chromium browsers have. So they're only like Firefox and Safari, but they're quite small in market share. So we try to support the most common browsers for the beginning. So if you Google developer documentation, then you get to this page. And this is like a book. So we have written a book with different chapters. So no matter where you click, you always end up in the same book. And then we go to installation. There we go to testnet. So maybe also to understand, we have mainnet and testnet. Mainnet is where you have the live production systems. And when you want to do developing as a developer, you usually work with the testnet where you get free tokens and can do all your coding and testing without having to pay for it. So we go to the Concordium wallet for web. It's the browser wallet. Here it also says it's a Chromium web browser wallet. So we click on it. And then you can add it to Chrome. Then you have to say, yes, I want to add it. And now you have the browser wallet here. One thing you have to do, you can pin it here. Then it will not disappear from your top line. So okay, now we have a new wallet, but of course this wallet is empty. So first we need to confirm the terms and conditions. Input the password. And we want to create a new account. So to create an account, you need a seed phrase. So a seed phrase is something like the last backup that you have to recover your accounts. So this thing you usually need to save somewhere very, very safely. So usually if you want that the user takes a backup of it and stores somewhere, and that's why we cannot paste. So I cannot paste anything in here. It's not working. But I have a small trick, which the normal user wouldn't do. The normal user would just input the 24 words here. But it would take me too long for now. So I'm a bit like cheating, and then I inputted my seed phrase. So now we have to decide where we want to create our accounts. We are on testnet. And now we have to talk a little bit about how to create accounts on Concordium. So Concordium is very different to like other blockchains like Ethereum. So before you can create an account, you need to have an identity. So how this works on mainnet is that you actually have to provide your passport to an identity provider and with a picture of you. And they will check and make sure that this is valid and then give you an identity. And only with this identity, then you can create several accounts. So first we have to do is creating an identity. Because we are on testnet, we can, on testnet, you can create whatever you want. Because we want that people can play around with different attributes. For example, they want to maybe be from a different country with a different date of birth, and they should be able to test this. So on testnet, we have this testnet provider. That means identity provider. And with this identity provider, you can create any identity that you want. Like you can choose your country and your date of birth. So we click on this. On mainnet, it's of course not possible. On mainnet, you need to provide your real passport. So it takes a bit. It's loading because it communicates with some backend services. And then it will open up a page where you can input the attributes to your identity. Yeah, it always takes a bit. You only have to do this once at the beginning. And then you have your identity. So that's our identity. It already has some filled-in names, John Doe, so we keep it for now. But one thing you should remember is that we created an identity which is from Denmark. So our identity is a resident of Denmark. Okay, we create this identity. So now we have an identity in our wallet. Okay, the next step is we need an account. So when you click on your wallet again, you can create an account. You have to choose which identity you want to choose. So at the moment, we only have one identity, but you could technically have several. And we create a new account. So now you see that the account is finalized on the chain. That means there's a transaction sent to the chain. And we need to wait a few seconds. So now it's finalized and we have the account actually available. So that's our account address. It's 34G. And with this account, one thing we need to do is we need to request some test CCT. So CCT is the native currency that we have on Concordium. And to send a transaction with this account, we need some funds. So on testnet, we can request some funds for free. And you see this transaction is still processed, so it's kind of pending. And in a few seconds, you will see 2 check marks, and then it's finalized. Now it's finalized. You see we already have the balance in our accounts. Okay, cool. Now we have an account, we have some funds in the account, and we can use the browser wallet. Okay, let's go back to the presentation. Okay, let's go overview over the smart contracts very shortly, so we know what we want to build at the front end, how we can interact with the smart contracts. So the first step was that we want to initialize a new smart contract. So initializing is like creating an instance of the smart contract. So yesterday you created this voting contract, and to initialize it, you had to input like 3 parameters. So we had to input the voting options, which were a list of country codes. So for example, Denmark, Germany, and India. And then we also inputted an end time. That means we want to have a time at that point the voting should be over. And we also inputted some sort of description. So these were our input parameters to the voting contract. Then the next step, what we wanted to do at the front end then is writing to the blockchain. So the one transaction that we had is that we had users, which we call Mr. X. They should be able to vote in the smart contract. And what they have to provide to vote, they have to put 1 country code as input parameter, and then they're voting for this country. So that will be our second step, that we try to build something at the front end where the user can vote. Then the third step will be that we will show how to read from the blockchain. We will display the tally, like all the kind of votes that the people already inputted into the smart contract. And then later we'll go to Concordium identity feature. I will look into this later, but first try to get the first things working. Okay, let's start a new project. So I'm here. So I'm showing you here. I'm creating a new folder, which I call demo. And in this demo folder, we want to create our new front end. Okay, let's see if we find this demo folder. And we will use Node.js and NPM to build a front end. So what this is, like Node.js is a JavaScript, and NPM is a package manager. So I show you first how these look like and where you can download them. So we will use Node.js. And it has a package manager, which is called NPM. So if you want to build the same front end, you would need to download it. They have a download section. And for your system, you can download it. You have to decide which one you need. Okay, I already have this downloaded. and we want to create a new project, and you do this by typing npm init. It creates a new project. So it will ask you about a few things like package name. So we can say we want to have Asia Vision, which is the Asian version of Eurovision Song Contest. And then it asks a lot of other things, which we just use the default values. We don't need them. Okay. So what happened now? So we created a package.json file, which contains commands and information about a project that we want to start. Okay, let's open it in our developer bar. Okay, we have the package.json file here. And we need to start, we need 3 packages. So we need 2 packages, which are from Concordium, and we also need a live server. So we will install these extra packages first. So we do npm in install. The package is called Concordium web SDK. And we want to have a specific version. We have just tested this version, so we want to install this one. So it will take a bit to install it. Then we need another package, also from Concordium. And it's the browser wallet, the API helper. And we also use a specific version of that. Probably some typos. I think it's called helpers. Okay. Okay, and then we need a live server. That's also a package that we install. So now we have installed 3 things, and if you look into our package.json file, you see you have installed these 3 things, the 2 Concordium packages and our live server. So now we want to start our front end, and I will copy the command over from our file that I already prepared, just because it's a bit long. So we want to have a start script. And what does this start script do? So what it does, it calls this live server. It then serves this index.html file, which we will create in a bit. And then it will also do something. It will mount the software development kit in a way so we can easily access it. So it's mounted to the root. And also the helpers package that we just installed, it will be mounted to the root, so it becomes easier accessible for us. Okay, before we can start it, we need to still create this index.html file. It's not there. So we create this by touch index.html. And now you can see we have an index.html file. Okay, I think we have all the packages and everything set up, so we can check if we can actually start a front end. So we execute the script, npm start, and we get a front end, which is very nice. Of course, the front end is kind of empty. There's nothing on there. So what I will do, I copy this over to Chrome, because we need to code in Chrome, because it's where our browser wallet extension is. So we have just an empty front end, which is not very interesting at the moment. So let's get some more interesting things going. So I will first copy over the front end that I already prepared, but I will comment it out, and then we will slowly build this. Okay. Okay. So I will remove everything what's in there, and then we will slowly build the same front end. Okay. Okay, let's see what we have so far. So we have a header. The header goes from here to here, and we have a body. So the body is empty. And what is in the header? So far, we only have a title, which is Asia Vision. So let's see if we get this title. So if I refresh, here, there's nothing at the moment. So if I refresh, I see now it's called Asia Vision. So we have correctly displayed the title. And what else? We have a style sheet here. So that's what it does, it's giving us some nice display of the button. So it makes the button and fields look nice. So you can also use a different style sheet or create your own kind of a style sheet to display things, but we already use one, so it's easier for us and looks kind of nice. And then we also kind of load the software development kit and the helps package from Concordium. So that's how we start. Okay, now we're gonna code something in the body, and what we will do is first we will line out what is our plan. So we will have different sections. Okay, we have one section where what we do here is that our first task will be connect to the browser wallet. Right? And display account. So that's our first task. We want to connect to the browser wallet, and once we are connected, we want to display the account address in the front end. So that's our first goal. The second goal, what we want to do is initialize a smart contract. So what we want to do here is we want to initialize the voting smart contract. Then the next step is we want to vote. So the user should be able to vote, to click a vote button. And what it does, or what it is actually writing to the smart contract or to the blockchain, writing to the smart contract. So we actually send a transaction to the blockchain. And then we want to also cover the second part, which is reading from the blockchain. And that we will do by displaying all the votes. And then if you stick around until the end, we have a bonus. So very, very specific feature, and I call it bonus. And it will be using the identity to create a zero knowledge proof, so something fancy. So we create a zero knowledge proof in the browser wallet. Okay, that's our goal for today. Okay, let's get started. Okay, first we need to connect to the browser wallet. So what we need, the user needs to press a button. So we need to tell the user what happens if you press the button. So you say connect to browser wallet. Then it's also nice to have a heading. So we can write. So when we have connected, we want to display the account. So we say connected account. We want to display. At the moment, of course, we are not connected to anything. So we would just write none. We are not connected to any account, but we need to give here an ID. And then later we can call this field and input a different value once we have actually an account address. So we call this account address. So now we have a button here, but of course the user, when it clicks the button, something needs to happen. So we make an on click, and when this happens, that somebody clicks on a button, we want to call the connect function, which is not coded yet, but we will do in a bit. So we are nearly done. We just make some breaks so it looks a bit nicer at the front end. Okay, let's see how the front end looks like now. Okay, now we have a heading, connected account. At the moment it's not connected, so it's just none. And we have a button. So what happens if you press the button? So I will show you in the developer console. What happens is we get an error because it says the connect function is not defined. So that's our next goal. We need to define this connect function so to get this error away. Okay, before we can code the connect function, we need something else. And it's when the page is loaded, we need to connect or get an entity of the browser wallet so we know how to interact with the browser wallet. So what we need is something which we call a client, which is null. At the moment, we don't have the client, but we want to have an entity which represents the browser wallet that allows us to talk to the browser wallet. So we create a setup function. And this setup function, it calls an Concordium the helpers package, and this helpers package will give us the client. So this function, when it returns, it gives us a client. So this is the client it's returned, and we put it into this variable, which is at the moment null, but once we have it from this helper package, we put it into the variable. Okay, so now we have a setup function, but we of course need to call the setup function. So we add an event listener. So when the DOM is loaded, so maybe I write this on top. When DOM is loaded, call the setup function so that we get a client. So we need to execute the function. Okay, let's see. Okay, what we do here is like when the DOM is loaded, we call the setup function. So it's at the beginning when the page is loaded. And the setup function will give us the client, which we put into this variable. And this client will then allow us to send transaction and read. Okay, we also store the account address in a variable. How we call it current account address. So the account address that the client returns, we store it in this variable, so we have it available. What's happening here? And what else we need is we also get we want to display the account address here in this field. So we get document, get element by ID, and we need to use the same name that is also written here. So we need to use this ID, which is account address. And then we can set inner HTML to account address as well. There's a problem.
Missing an arrow. The arrow is not an arrow.
Oh, okay. Oh, I see. Okay, cool. So let's see if it's working. So what we're doing is here we call the setup function, get a client, and when we get a client, we connect to it and get the account address. So let's see if that works at the front end. So now if we click the connect browser wallet, we get a pop-up and we need to confirm that we actually want to connect to this website. So you can see here this value. It means localhost. It's also here. So this number always appears if you run a website locally on your computer or laptop. And if you would run or if you would open a website in the web, then it would be, for example, Google or something, or Wikipedia. But this is localhost, and you need to confirm that you want to connect to it, that you trust the website. Okay, connect, and then you see I get the account address, which is the same that's also in my browser wallet. Yeah, cool. So we achieved the first step, which was we wanted to connect to the browser wallet and display accounts. So this step is completed. So let's go to the next step, which was initializing a smart contract. So for this, I will copy paste the buttons because otherwise it's too much coding. So the buttons are very similar, so we will go through them. So we also have a heading which says we set up a new song contest, and then we give some information to the user that they should input a comma-separate list of countries that they want to provide that the people can vote for. And then remember, we had 3 inputs parameters. We had a description, we had an end time, and we have the country codes. And then we have the same thing then here. We have a button, and when the user clicks this button, we call a function that we haven't coded yet, but we will do in a bit. So let's see how this looks at the front end. So we have a new section here. Maybe make it here. So we have a new section here, set up a new song contest. And here the user can input a new description. So you can input whatever you want, and you can also choose a different date if you want. Just make sure it's a date in the future, so we can still vote for the election and it's not already over. And here you can input your country codes. Cool. So if you click on it, we'll get an error because we haven't coded the setup election function yet. Okay, that's our next step. We want to code this function. Maybe do it. Okay, first, what do we need? We need the values from the fields. So I call it get values from fields. So we had a description field, and you get this value. So now we also need to get the ID of the value of that field. So this field we call the setup election description. So we get this ID, put it in here, and we call value. And it will give us the value which is written in the field. So that was our first input parameter. Now we need two more. We also have the end time, which was called end time. And we also have the voting options. And to showcase that we get the values correctly, we console log them out first in the console. So we do some changes here. We just convert this. And also, I think we trim this so we get a nice array. It's just so it looks it's a bit better. Okay. So let's see if we get these values in the console. So now if we look to the console and we click on this button, you'll see all these input values that we had in this fields. So you can input another value here, and then you get an additional. Now Russia is part of the contest as well. Okay, cool. So what's the next step? The next step will be send a transaction to the blockchain. That's what we try to achieve. And we do this by, we need our client again. We send a transaction. And first of all, the client needs to know which account it should use. So we need the account address, which we already have from the browser wallet. And then we also need to specify which transaction we want to send, because there are two types of transaction that you can send on Concordium to blockchain. So we Concordium. So it's called init contract, I think. So it's just we tell them that we want to initialize a new contract. Now we need a few more things, and I will write down what these are. We need a raw module schema, and the raw module schema will help us to serialize the input parameters. So I will explain what this is. So we need the input parameters here, and we also need, I think I call them general values, transaction values. So our input parameters we already get from the top, so we can just input them. And the raw module schema is something like the interface. So if you're familiar with Ethereum, it would be something like the ABI, the application binary interface. So maybe think about it like this: the smart contracts, they interact with these values in a more compact manner. So these values will be in a compact way, and then so we in this value the human person can read it, but then we serialize it to a compact form, and then later, if you get a return value, we need to deserialize it again to get it back to a human readable value. Okay, let's get the raw module schema. So I copy paste these values, but I can later explain where they come from. But for now, they're kind of magic strings. So we have a raw module schema here, which is a magic string. And we have also the module reference, which is also a number, which I can later explain where it comes from. So for sending, okay, wait. We need a raw module schema here. And then we need a few inputs here. I maybe copy this as well because it takes too long. Here, that's the input we need. So there's a few things we also need. We want to specify how much CCD, the native currency we want to send with the transaction. At the moment it's 0. And we need to specify which module reference we need, so which smart contract we want to deploy. And then the name of the smart contract, which is called voting. And then we also give a number how much energy we want to spend. So this value allows us to make sure we're not spending too much money. If it would be more than this value, the transaction would be rejected. Okay, so once we have sent this transaction, the client gives us something, the transaction hash as a return value. So we can output this transaction hash and see if it's working. Okay, let's see. Cool. Okay, let's try if we get a transaction hash out here and create a new smart contract instance. So if you click the button here, okay, it says site is not whitelisted. That means we need to connect the browser wallet first. Nice. Now the browser wallet gets all the information it needs to send a transaction. So it gets the sender account. It gets the module reference that it needs to know where it can deploy the smart contract from. And then the name of the smart contract, we send 0 CCD, and how much energy we want to maximum execute when executing this function, with this transaction. And also these are the input parameters. So we can send it. We get a transaction hash here in the console. There's another way how you can get a transaction hash. So you can go to your transaction logs, and here you see this was the transaction we just sent. So you can click on it, then you get a transaction hash. And now we can exploit on the block explorer. So we have CCD scan, which is our block explorer. And just make sure that you're on testnet or not on mainnet. And if you input your transaction hash, you can click on it, and then you get additional information. So this was a transaction we just sent a minute ago. And yeah, you can see that we deployed a new smart contract, which has the index 2405, and it's a sub-index. So one important thing to understand on Concordium is that all smart contracts, they have an address. But this address is like an index and a sub-index. So that's very different to how maybe addresses are on Ethereum. And how it works is that when you deploy a smart contract, it gets the lowest index that's possible. So the first smart contract that we deployed on testnet was 1, and then the second one is 2. And now we are already at 2,405 smart contracts that we have deployed on this blockchain. That's how it works. Then there's another area where you can explore your transaction hash. So we have the dashboard, testnet. So when you go to the dashboard, it shows you also some information about the blockchain, and you can go to lookup and put in your transaction hash, and then you get also additional information. You can click on this, and then you see that we just initialized the smart contract, and it's called voting, and it has these index. Cool. So I think we have already achieved our second task, which was initializing a smart contract. Now I put it in the wrong section. So we initialized the smart contract that we already achieved. Great, that's our second task. So now we go to the third task, which was we want to write to the smart contract. It means we want to execute a vote function. And I will also copy paste it because we don't have that much time. So it's the vote section. And we need also a vote function, which is here. Okay, so let's go to the vote function. So what if vote function, the user can input a country code and vote for it. So the client here, this transaction is actually very similar to the one we already wrote. The only difference is that we use a different transaction type. Now it's an update transaction, not an initializing a new smart contract. And we input a contract address here instead of the module reference. But otherwise, it's very similar in the way how we write a transaction. Okay, let's see how this looks at the front end. Okay, now we have here voting section. We can input a country. It's India, so let's vote for India. Okay, so it's not whitelisted. It means we need to connect the browser wallet again. And now you see we could execute the vote function again. It's very similar to the other function I already showed you. Okay, now we have the third part achieved, which was voting. So let's go to the fourth part, which is displaying the votes. This is literally reading from the smart contract. So I also copy paste it. So what we will do here, we will display the results. We execute a function, the view result function, when the user clicks on the button. And then we have 3 fields which we output data that we get from the blockchain. We have a description field, the end time, and a tally, which is all the votes from all the people who have participated in the election already. So we need this view results function. Okay, let's go through the view result function in a bit. So first, we also get the contract index, which the user can input at the front end. And then we do something different because now it's reading to the blockchain. So we don't send a transaction to the blockchain anymore, but we only simulate the transaction locally on one node. So it's only the one node that's connected to the browser wallet that executes this. And we have to give the contract address that we want to execute the simulation, and then also which method or which entry point of the smart contract we want to execute. And then we get a result, and this result I need to deserialize. I told you before already that we have to serialize and always deserialize the values, just because the smart contracts store value in a more compact manner than maybe how humans would read the values. So this is a function we can call to deserialize the return values. And then what we do is just outputting the values into the fields we have at the bottom. So let's look how this looks at the front end. Let's check this. So now we have a section which is called results. And we can click the get results, and then we get the values from the smart contract. So we see the description of the smart contract, when the end time is, and we already see that some people already have voted. So 3 people have voted for India and 1 for Germany. Okay, so before we go to the bonus, so I told you at the bottom that we will do some fancy zero knowledge proofs, or we create them. I still have to, I think, show to you or explain to you where these 2 values come from, the raw module schema and the module reference. So when you listen to the presentation yesterday, then Caspar was executing this command to deploy a smart contract to the blockchain. So I will just show you, and that's where you get the get this reference value. So that's what Caspar did yesterday. So I'm not explaining too much what it is, but it communicates with the node and deploys the smart contract that you have compiled. And because we already deployed the smart contract yesterday, we will get an error. We cannot deploy the same module again, but it will give you this reference that we need. So it gives you this module reference 8985. And this is the value that we're using here. Or you can use here if you use the smart contract. That's where this number comes from. So it's a different number yet now because I think we changed the smart contract roughly, and every time you change the smart contract, you get a different hash. So let's also understand where this row module schema comes from. So also Caspar showed you this. I will add some extra code which will help you in your coding to use the front end to display these row modules, these schemas. So we have a section where we can upload a schema. So I add this. And then we do also an upload schema function. To the code. Okay, so let's first see where we get the schema from. So Caspar yesterday executed this command, which you do in the folder where you have the smart contracts. So in the smart contracts, you can write cargo Concordium build, which compiles your smart contracts. And then you can say schema out schema bin. So what this command does, it compiles your smart contract and outputs the schema in your current folder. And now if we look what we have here, we have a file which is called schema bin. And this schema we will need to upload to the front end, and then we get this magic hash, which is ADAQ. So let's look how this looks at the front end. Now we have a section which means upload schema. So you can choose a file. You just create a schema bin file. If you click on it, you can upload it, and then you get this magic value. And again, the schema, it's a way, it helps external tools to interact with the smart contract and serialize and deserialize the values. So we need it for the front end to easier communicate with the smart contracts. Okay, now I think you understand where these two values come from. They're not magic values anymore. Okay, now let's get to the bonus, which was we want to create a zero knowledge proof. So what is a zero knowledge proof? It is a small thing which proves something while not revealing something else. So you can prove, for example, you are older than 18 without revealing that what your actually date of birth is. So we will do this. We need a function. This is this ID checked vote function. And instead of what we will do, instead of that the user, when clicking the vote button, remember the user was clicking this vote button here. Instead, before the user can click this vote button, we will check the ID of the user, create a zero knowledge proof, and only when the user is from a different country than it's voting for, then we will allow the user to vote. So how does it work? So we have here this function ID checked. These are the input values we get from the input fields. And then the main thing that we need for the zero knowledge proof are these two things. So we need a statement and we need a challenge. So the statement is something like it says, is a sentence which says what I want to prove. So I want to prove that the country of residence of my account is different to the country code that the user is voting for. So I say it's a non-membership here. So these two should be not the same. And then we also need a challenge. So the challenge is just a random value. We use AAA. But in a production system, what you would do is usually that your backend service would create some challenge. And in that way, you can make these proofs expire. Because, for example, you don't want that somebody can use the same proof, which is already 20 years old. Then maybe the country of residence has changed. So it's a good practice to include a challenge, make sure your proofs expire. Okay, what we do here, we have the client, we request the ID proof, and we input these three things: the current account address that we want to prove, the statement, and the challenge. And if it's successful, it means if we get a proof back, then we allow the user to vote. Otherwise, we give some output and say the person is cheating. Let's do this at the front end. Okay, we connect to the browser wallet again, and now we vote. And let's vote for a country that's different to the residence of the user. So remember, the user was from Denmark, so let's vote for India. And now you see that the browser wallet is creating a zero knowledge proof, and you see check marks. It means that the browser wallet is able to create a zero knowledge proof and prove to the front end that the resident is not one of the following, is not part of India. So it's not, the residence is different. It does not say which resident the account is from, but it proves it's not from India. So I can accept it. And once it's accepted, I can actually vote. So only then the front end allows me to vote. So now I can actually vote for India. So we vote for India, and we get a transaction hash. So we could look up the transaction hash on the Log Explorer again. So let's see what happens if we try to cheat, okay? So we cheat and we try to vote for Denmark. Remember, we are from Denmark. So now it's not working, you know, it's not green anymore, it's gray, and it says it cannot create this proof because it's not possible because, yeah, we're actually from that country and we cannot even click. The button is gray, so we cannot click it. So that's how we create a zero knowledge proof via the front end and using the browser wallet. So I hope that was interesting, and I will go back to the presentation. Okay, here's my presentation. Okay, we covered the Concordium identity feature. We looked into zero knowledge proof, which was the fancy bonus. And just we give you an overview how you would build this in a more production-ready system. So in the production-ready system, you would have to do some signature checks in the smart contract as well to check the identities of the user. How we would do this is that we look at it first, that the front end would send a request to the browser wallet and say, okay, I want to check the identity, similar to what we did today. Like we create a zero knowledge proof, send it back to the backend service, and it would confirm there that the zero knowledge proof is valid, and then create a signature. And this signature we would send to the smart contract and then check it in the smart contract to also make sure that, yeah, we have a check on chain and people not cheating. Okay, so like today we did something a bit similar because we don't have that much time. We created a proof, but then just enable or disable the button at the front end. So it's a simpler version, but it's a version we can do in a demo in now. So these two parts are not part of our presentation, but if you're interested in it, we have an example, smart contract, which do some signature checks, and we also have a demo, which we call Gallery, where we have a backend service that checks the zero knowledge proof. So if you're interested in these parts, you can explore them. Okay, let's explore why you might want to build on Concordium. So I hope you already maybe have seen that the speciality of Concordium is that it's a blockchain with some identity features. So if you go to our website, you see the following, that it says something like Concordium is a science-based proof-of-stake, public, permissionless blockchain with identity built into the protocol layer. But it's a very long sentence, isn't it? So we break it down a bit and highlight the words, what they mean. So Concordium is a blockchain which stores transactions that cannot be deleted. So it's an immutable record of your transactions. It has a consensus algorithm, which is the proof-of-stake consensus algorithm. So it's more eco-friendly than, for example, Bitcoin. It's a public blockchain, so anyone can run a node. It's permissionless because everybody can create an account as long as you have a valid identity. So there's no restriction on that. And we call it science-based because we are very closely linked to universities and use the research and actually build in the research as well into the protocols. So we are up to date in this area. And the very special thing that we have is these identities. So you need to have an identity check done before you can create accounts on the Concordium chain, which then allows you to create these fancy, interesting use cases where you check the identities of the people. Okay, some more points where you maybe can look into if you're more interested in. So if you're interested into these identity features, the main thing which might be interesting are these zero knowledge proofs. And what we try to do here is we try to balance the privacy with accountability. So these two things, on the one hand, we want to have privacy for the user, but a lot of businesses need to identify who they're interacting with on the blockchain to do their business. Then the Concordium blockchain also has these smart contract capabilities similar to Ethereum or Solana. So anything you can build on their blockchains, you can probably build on our blockchain as well. So we have a growing ecosystem of dApps that are developed and partners that we are working with. So you can explore these two links. And then we also are a growing company. So we're always looking for talent. So if you think you're good, if you want to explore the team, you can explore it here and even look at the positions and maybe apply if you think you fit in the team. And if you want to know what the Concordium is doing in the future, we have some roadmaps and company website to explore. And here we give you some ideas what you can work on for the hackathon. So these are mainly ideas for how you can use the identity in the blockchain, but feel free to have any other kind of ideas or build some other use cases. So do you think in the future that use cases where maybe employment relationships, or if you have certificates from your education or from other profession that you did, or any kind of cards where you maybe have to collect points, that might be a good use case for using the identities on the blockchain, or any kind of thing where you need to check something about the person. So for example, check their age or check who they are in social medias, or if you want to ensure that maybe people get something if they participate in an event, then these kind of questions can probably be answered with identities and be useful to build on the blockchain. Okay, here we have some additional resources. So I think when you start working on it, it makes sense to go through them and see if some of the maybe frontends are useful for your work. And for front-end development, maybe you can look at the Node SDK, which gives you a lot of examples to get started with. And we also have tutorials, which some you might find interesting. And the developer documentation is also good to start with if you build front ends. And if you want to see the full dApps, we have several examples which already include the hosted link where you can play with the front end, and we have the front end code, also smart contract code, and often also a tutorial. So these are full dApps which you can explore. Okay, any question that you have so far? Anything that you find interesting? Maybe I stop sharing.
Hi Doris. I hope I'm audible.
Hello.
Yes, Kamal,
I don't
please
know
go
if
ahead
I'm
with your
audible.
question. Yes,
Yep.
you're audible.
Yep. Thank you. So Doris, I wanted to ask, like, the ZKP, the proofs that are generated. Let's say I give you an example, like, the college means if I am enrolled in a university, and then if there's a proof generated, like, I am enrolled in an IIT, say, so the proofs are verified by the university, and how that process goes on, can you tell me?
Yeah, so at the moment, the identities in Concordium, they are similar to what you find in your passport. So it has maybe your name, your surname, your date of birth, and then your nationality. So similar fields that you find in your passport. So these information you can prove, and then you need to build a backend service which checks these proofs. So if you're interested in it, we have this gallery example. So maybe I can go back to that. And it builds a backend service here, gallery, which then checks these zero knowledge proofs at the backend. So that's how it would work.
We're also working on something we're calling ID3, which will come out later this year, I think, where we will have support for creating, for example, like a university certificate, and that you can then prove that you have, that you have this education. But that's not something you can do right now. I mean, you could build a smart contract that will do that, and that could be an interesting thing to build in this hackathon if you want to.
No, not about this hackathon, but in my previous hackathon, I had built something like that on Polygon using Polygon ID. So I was just thinking if I could build the same on Concordium.
I mean, you can build that with a soulbound token, if you know about that. Yeah, so that is possible.
Yeah, I think it would be possible to have these smart contracts and include the logic that you need for your employment certificate in a smart contract for the time being. And yeah, once we have Identity 3.0, then I think these things will be available.
Yep, sure. Thank you for answering.
Any more questions?
Also, apart from Rust, is the Concordium team trying to include other languages as well in the future?
So at the moment, what we have is Rust. So when you code as a smart contract developer, then Rust has the best support to compile your smart contract into a Rust module. So it's WebAssembly, but you can choose any other programming language that also compiles to WebAssembly. But the reason why we use Rust is that we have the best support for that. And we also recommend it to use it if you want to start with that.
Yes, it wouldn't be very easy to use a different language at this time. But I mean, there are plans to add more languages eventually, but we don't have any concrete plans right now or any timeline for that.
Okay, I got to learn Rust then.
Yes, and it's
Really
also
interesting.
a favorite language between from a lot of developers. I think Stack Overflow ranks it's number one for the last 5 years. So
Okay, any more questions?
Yep, gotta check it out.
Hey Casper, you told me that the smart contract should be, validated. So should validate the signature from the backend before accepting a vote, right?
yes, in a complete
Okay.
secure
So, so,
solution, yes.
so I think for validating the signature, I think the backend needs to be supported by some hashing algorithm, isn't it? I just wanted to get a short, nothing else.
Yes, the smart contracts do have support for verifying different hashes. I don't. It's like SHA-2 and
Yeah.
KCAC or whatever it's called, and a few others. Yeah.
All right.
Cool. Any more questions? Okay, I guess we can end it now. So thank you so much, Doris, for an amazing session. I personally learned a lot, and I hope the viewers did too. And guys, we have our opening ceremony tomorrow and also another workshop at the same time. So you can join us again. And I'm sharing some important links. So it has the link to Concordium's Discord and our Discord where you can, ask any questions that you might have. And also, if you want to connect with Doris, we have links to that as well. Okay, see you again, everyone. Bye bye. Thank you so much for joining this.
Bye, everyone.
Bye. Thank you.
Bye, see you.
Thank you so much, Doris. It was nice to see you.
You're welcome.